Hello, so welcome to, I think this is the 8th stream of this weird kind of exquisite corpse thing I'm doing with Jan Sesnick, where each week we take turns to implement the audio for this strange Unity project I've made. I guess I'll start by just quickly running through the game to remind ourselves where we are, where we're starting from. I know that last week Jan implemented a bunch of crunching sounds for the doors.
Human.
There's a few other things, I think. There is something really satisfying about the way the door, the sound just abruptly changes whenever we walk through a door. Yeah, and then this is the other thing Jan added, this pitch changing kind of ambient sound. Now, I'm not sure if I've got it set up for the right mic. I don't know if this is... Oh, I think I can hear myself. Okay, and when I go down here, we hear Barbell sound get occluded, and I think that's basically where. But I think that's basically where we've got to. So what I want to do this week is I want to finish working on that audio occlusion system for Barbell. I'm going to explain what I want to do, but before I do that, I want to make a few quick changes to the Barbell occlusion script. So this is the script that that basically sends a signal to our PD patch to apply a low pass filter. So when Barbell is behind something, when it's occluded, we turn up the low pass filter so it gets kind of all muffled and it sounds like it's behind something. But what I want to do today is I want to update it, and I'll explain how I want to update it in a second. But first I want to actually add in some code to actually visualize what we're seeing, what the occlusion code is doing. Because I think this is one of those things where it's easier to understand what's going on if we can actually see what's going on. So what I'm going to do is, for the occlusion stuff, I'm going to draw some debug lines in the game so that we can see exactly what the code thinks is supposed to happen. So I'm using the debug.drawLine command, which just takes two positions. So we'll in this case, we're going to draw a line if there is a clear path or a clear ray from the player's position to Barbell. That's the big red sphere. So we can just grab player position in this case and Barbell position, and I'm going to give it, I'm going to make it yellow so that it's really easy to see. And I'm also going to draw a separate line if we didn't hit Barbell, which is just going to be, I'm going to use the same command. Again, we're going to start with player position, only this time we're going to grab the point where we actually hit. So our physics.raycast function basically fires out a ray in a particular direction and returns some information if it hits something. So in this case, the hit variable contains the point that ray hit something. And I'm going to give this one the color blue. I'm not using red, although red is quite a common color for this kind of thing. one of the reasons I'm not using red is because you have those big red rooms where it's just going to completely disappear. The other reason I'm not using red is because I'm red-green colorblind. And red is a really bad color for like highlighting information for me because I tend not to see it. Like a kind of common example is when people like have text and they try and use a red font to like draw attention to that text. But for me, like if the rest of the text is black, my eyes will just skip over the red text, and it's only if I look closely that I actually even realize that it's red, because the contrast just doesn't work for me. Anyway, that's a bit of a distraction. Let's see if I've done this right. So as soon as I start, we should be able to see a yellow or a blue line, or not. Let's check. Oh, Barbell isn't actually active yet. Wait. Oh wait, hang on. I think I need to turn on gizmos. Ah, there we go. I need to turn on gizmos. Okay, so at the moment, Barbell is hidden in a box in the sky. So it's only when it starts falling. Okay. So at the moment there's not that much that will kind of block it, but once it falls down we should see this line turn blue. There we go, because the ground is now in the way. And then if I come over, let's see, if I come over here, yeah, so we see it turns blue and then yellow. It's fantastic. So we know exactly what our occlusion code is doing, but what I want to do this week is, you can see here that if I do this, for instance, Barbellith, our code thinks Barbellith is not occluded at all, but visually we can see that it is partly occluded. So ideally what I would like to happen is I would like to be able to send partial occlusion information to my PD patch, so that it's not just an on-off signal. It's we can have like halfway occluded if Barbellith is kind of halfway behind something, or we can have like 3/4 occluded if it's mostly behind something, that kind of thing. So what I want to do today is sorry, I was reading the chat. What I want to do today is I want to basically fire out multiple rays to try and encompass the majority of Barbellith. And the way I'm going to do that, I already started on this last week. In fact, let me just quickly add in my debug lines here, just so we can see the same things for these. What's going on with this? Why are my braces? Do I have like an extra brace? I do. That's weird. That better? Okay, so yeah, so what I want to do effectively is, in fact, I'm gonna come over to a drawing program here. I'm gonna draw a, oh, that, I don't see that very well. It's gonna be a yellow circle. You can just imagine that it's red. So this is our Barbellith. And let's see. Actually, I'm regretting my choice of colors. I'm gonna change this. It's not going to be red. It's going to be a white circle. Okay, this is Barbellith, and what I am going to do, or what I want to do, is I've already got this kind of center point, so that's where I'm firing a ray at the moment, and I'm going to take advantage of the fact that Barbellith is a sphere, which means that even though that's a 3D object, if we're thinking about this as a 3D object that's projected onto a 2D screen, we can think of it as a circle. Because Barbellith is kind of a perfect sphere, at any position we view it from, as far as we're concerned, it's kind of just a circle, a flat circle. So what I'm going to do is I'm going to basically project rays onto the edges of that circle. So I do something like this. So that then we can have, for instance, let's see, so we could have like this section occluded, and then we only have 3 points returning that they can hit it, which means we get like a small or a fairly large amount of occlusion, but not complete occlusion. So let's see. So I've started writing the code for this, but all I have at the moment is really a for loop, and then it's just repeating the code from up here, which is firing a ray directly at the center of the sphere. So what we need to do now is we need to figure out the exact positions of these individual points. And what's useful here is the equation for a point on a circle is actually really quite simple. It's basically your x is, this is going to be some quite ugly writing, I'm afraid, because I'm doing with a mouse. Your x is basically sine of the angle of that point. So if you can imagine, this is our kind of 0 angle, then to get the position of this point, we just grab this angle here. And because each of these points are equally spaced, we know exactly what angle to use. For a full circle, we're talking about 2 pi. So basically this one is, because we've got 8 points, this point will be 2 pi over 8. This one will be 2 pi over 4, and so on. So we know the angle. So in order to get our x position, we use this function. In order to get our y function, we just use cos. So basically, same deal, like that. So we know how to get our points, assuming we have a flat circle. We don't actually have a flat circle because we're in 3D space, so that circle is going to be kind of, we can think of it as rotating around based on where we are looking at the sphere from. But to begin with, we're just going to use these functions. We're going to assume that Barbell is a flat circle. And then we'll figure out how to rotate that in 3D so that we can actually get the correct coordinates. So let's see. So I need to come back to my code. And okay, now I'm going to cheat a wee bit because I did do a bit of homework because I didn't want to spend the whole stream figuring out how to do maths. Yes, so let's see. So first thing we're going to do is we're just going to calculate an index variable, which is basically just, we can think of this as our angle, right? So we've got 16 points, and our angle is just, it'll be different for each of these points. So we'll start by dividing our I value by 16. So we now have a value that goes from 0 to a bit less than 1. And then we just multiply that by 2 pi. So this gives us our index. And then, let's see, so in fact, I'm going to swap these around. Pause should come after that. So what we're going to do is we're going to set this pause value as a new vector 3, where the x value is that sine function. Oops. And we just pass in our index. In fact, I'm going to rename this to match my diagram. I'm going to rename that to angle. So this is our x value, and then our y value is the same, but with a cos function instead of a sine function. And we're just going to set the z to 0, because again, for the moment, we're treating this as though it's a flat circle. Okay, so So the pause is now a point on a circle that starts at 0, 0, and has a size of 1. Now that's not actually the case for our particular circle. Our particular circle is scaled by the size of Barbellith. So what I'm going to do is I am going to, let's see, if I multiply this by vectors, oh no, sorry. If I multiply this by, no, is it barbellith.localscale dot x. Local scale is Unity's scale of the Barbellith sphere. Now, we don't want the full scale, because the full scale, I think it starts off at 1, or we can think of it starting off as 1. But that's for from one side of the sphere to the other. But because we're calculating the angles as we go around, we're actually we want the radius of the sphere, not the, I want to say diameter, the radius, not the diameter. So I'm going to actually reduce this, and I'm going to make it so ideally, or if we want the exact edge of the circle, we want to multiply the scale by 0.5. But I think I'd actually like to just make sure that there's no possibility of our rays going past it, because I'm slightly concerned that if we use 0.5, then there's a chance that the ray might go past. I'm not sure, but I'd rather not take the risk, so I'm going to use 0.49 so that we're just slightly inside the outer edge of the circle, which should work just as well for our purposes anyway. So, okay. So this gives us a circle that is the same size as Barbellith, but it's not in the right position. So the next thing we need to do is add on Barbellith position. Okay, so we've created a basic circle. We've scaled it to the size of Barbellith, and then we've placed it at the same place in the world as Barbellith. And now I need to update my debug coordinates. We're not going to Barbellith position anymore. We're going to our new updated pause, which is basically the circle that's centered on Barbellith. And this isn't going to be quite right, because I still have a few things I need to do to make it properly work in 3D, but hopefully once I boot this up, we should see something, and it should be something that we can work with. Okay. Okay. Okay, so we can actually see a bunch of rays now, right? And Barbellith's still quite far away, but it looks like they're... Oh. Okay. So this actually looks... So if I don't move left and right, this looks right. It looks like we do have rays being fired at the kind of full circle. But you'll see that as I kind of come round, we see the problem with me treating it as a flat circle in 3D space, because it doesn't... We're not rotating those points as we, the player, rotate. So this isn't... I'm just going to move it on to the stone circle so we can just check that the individual rays are kind of occluding or not occluding as we want them to. But they should be. So I'm going to come around this side, and if I do something like... Yeah, so we can see... And actually, our patch is already reacting. I think I might need to make some small adjustments to the patch. But you can hear that the occlusion is more granular now. It's kind of reacting a bit better. Anyway, that's the first step. So we have something that we know that it works. We just need to make sure that it works in 3D, right? So for this, I'm going to check back on my homework. So I've got this line here that I don't think I have in this code. I can't remember why I have that line. Anyway, it's fine. We'll just ignore that for now. So the important thing that I want here. Oh, okay, hang on. I do need to calculate our. So the important thing here is we're going to use this function quaternion dot from to rotation, and I'm going to say up front I don't understand how quaternions work. As far as I'm concerned, this is just kind of magic. So what this function does, though, is if you feed it a point in 3D space, and you give it a specific direction. So if you give it like a direction that you're starting from and a direction that you want to end on, what this function does is it rotates that point so that it's facing the new direction. So if you think of it as us, our circle starts off basically facing towards the z-axis, and what this function does then is it lets us rotate that circle to an arbitrary direction, which is exactly what we want, right? Because as a player, we're kind of constantly moving around, and we're changing what angle we're looking at the sphere from. So this is the function that we want. So I'm going to grab this now. The way this function works, let me just double check. Yep. So the way this function works is you basically give it two vectors. So the first one is the vector that the circle is currently on, and the second one is the vector that you want to move it to, which is why I need this dir vector, because that's the vector that we're moving to. So I'm going to calculate that, and we can calculate that just once. Oops. Because it's the direction that the player is looking in. That's the direction of the circle that we want to project. In fact, so dir will be. I'm just going to copy the code I wrote earlier. I'm just going to copy this. Well, this is wrong. So this will be Barbellith. So basically, oops. Nope. So basically, what this line is doing is it takes Barbellith's position. In fact, this should be player. It takes Barbellith's position and it subtracts the player's position from that. So what that does is it gets basically a vector that points in the direction that the player is facing. Or sorry, the direction from the player to Barbellith. And then we normalize it, which just means that it is set so that vector has a length of 1. And then we can feed that into this quaternion from to rotation function. And basically what we do here is we create a quaternion. Again, I don't really know what a quaternion is or understand it at all. But when we multiply our original circle position by this quaternion, it basically rotates that position, that point, to the place that we want it to be in. And I think that's all I need to do. There are a few kind of niggles that we'll need to come back to that I discovered when I was testing this, but we'll do this first because that stuff makes a bit more sense. Okay, anyway, sorry, I was looking at comments. Let's see. Okay, here we go. I'm really curious how it seems to fall first before we see it. I don't know what's going on there. Right, okay, so here you can see that as I kind of move around it, our points kind of stay the same, right? They're all kind of pointing at the circle. But you do see that when I get here, it does this weird kind of rotating thing, as though the points themselves are rotating around the edges of the circle. Now, I think the reason for this is that we're basically... Oh no. Like... Oh no, no, we're good. So I think the reason for this is that we're basically, at this point, we're kind of looking at Barbellith from behind as far as Unity is concerned. We're looking at it from behind. So you see that if I go around this side of Barbellith, it doesn't do that weird kind of rotating thing. So I think the problem here is that we're working with negative coordinates. So I'm going to fix this by just adding a simple if statement. And again, I'm going to need to check my homework. Let's see. So basically, what I'm going to do is I'm going to create this mult variable. So just multiply it. And then I've got, and so normally it's 1. Obviously, if you multiply anything by 1, it doesn't change. You get the exact same value out that you started with. But if we, the player, are behind Barbellith on the z-axis, then we're going to flip mult to be -1. So we're just going to invert this value. And I forget how I actually used this. Let's see. Oh, I put this in the wrong place. Just a sec. So then in our quaternion equation, we're basically going to invert. So we're going to use this mult variable to invert our initial direction. So that's the direction of the z-axis. And this should mean that we don't get that weird kind of rotating thing. To be honest, I'm not entirely sure that the rotating thing will have much of a negative effect. But it is a bit weird, and I'd rather we didn't do that. So I'm going to do this, and I think that's everything we need to do. I guess we're going to find out. Okay. So hopefully, once we get closer, we will see that the lines don't rotate anymore, and it just works the way we were kind of expecting it to work. Okay, so they're not rotating. They maybe do a wee jiggle as we kind of pass the if statement, but that's fine. This now is basically working, I think. So I guess now we get to test it against the standing stones. So if I get close enough, let's go to one of the bigger ones. Now I think I do need to change my PD patch, because I think it's got quite a long kind of fade in on the occlusion. But hopefully you can hear that. And if we get right underneath, this. Anyway, I think that's basically working. So that's great, right? So what I want to do is I'm just going to quickly alter the line function in my PD patch, because I'm basically, where are we? We're here. Oh, I need to try and decipher the PD patch again. Okay, so it's here, right? And yeah, so what we're doing is we're taking a second. So every time we send a new occlusion value to our patch, we ramp up from the current value to the new value over the course of a second. And I think that's way too long. We don't need to spend that much time. I'm going to go with 100 milliseconds. And hopefully that makes sense. Because the thing is, now we have this kind of granular occlusion setting. Oh, that was nice sounds. But now we have this granular occlusion setting. We don't really need that kind of hard-coded, like long fade-in, because the granular nature should ensure that we get a nice fade-in, I'm hoping. And now if I do something like this, you can see here that it kind of, you can kind of hear it. I don't know, I'm not entirely sure this is quite as effective sounding as I was hoping it would sound. But it's now at least a lot more, it's a lot more realistic, hopefully. Oops. So what I want to do, because part of the reason I wanted to do this was that I noticed that in the final scene there were some weird things happening with the occlusion as you go up the spiral ramp, where it would kind of go in and out of occlusion, even though like most of, like you have this enormous, oh, what's happened here? The door broken. Okay, I'm going to skip forward. Nope, this is the wrong one. There you go. So even though Barbell itself is enormous and is taking up a big chunk of space, because of the spiral staircase, you could hear it kind of, the occlusion kind of getting turned on and off. Whereas now, it shouldn't happen, because there should be enough of the rays hitting Barbell at any given point, and that you always hear it fairly unoccluded. That's what I'm hoping. It's just especially in those spots once we got to the top. But obviously by that point you're kind of, the path is underneath you. It's kind of still doing that. Oh, in fact, actually, so important point here, I think I've got my Barbell's occlusion script on the wrong game object. So I think my Barbell's occlusion script is, if I grab my mouse, where's my mouse going? I think my Barbell's occlusion script is actually on the player object. It's on the Barbell's object, but it's treating the player object as the source. And actually, the player object is not where our audio listeners. It's not where our kind of virtual microphone is. Our virtual microphone is actually on the camera object, which you can see is kind of up from the center of the player object. So that's what's happening here. You can actually see the center point is actually below me. That's why we have these blue lines at the top of the circle, at the top of the sphere, even though that's not actually where our ears are in the scene. Anyway, let's turn it off. So what I need to do is, if I grab Barbellith, I need to change it so it's not the player that we're kind of directing these rays from. It's the main camera. And now, if I go back to that scene, let's see. So I'm just going to jump to it. There we go. And oh, okay. We're not seeing the rays anymore. And the reason we're not seeing the rays is because they're basically being shot directly out of the camera which means that the camera is always looking along the lines directly, and I guess Unity's debug draw line function doesn't draw that as like dots on the screen, which would actually be kind of helpful, but I guess it doesn't do that. So I think we'll be able to hear once we get closer to the top that the occlusion is still working. It's just we don't see the debug lines anymore. So you can hear it, it's doing kind of weird things. It's kind of jittering in and out as I guess different lines are being included and not, which... Oops, where's my mouse? Yeah, see, you... Oh. And I guess here our lines are being occluded by this platform still. Kind of wondering if maybe I've gone to all this trouble and what I really wanted to do was just disable the occlusion script for this last scene. Maybe I did just want to disable the occlusion script for that last scene. Well, I'm gonna leave that for now. I'll come back to that, I think. Okay, what do I want to do for the rest of this stream? Well, I think something I'd kind of like to do, now that I have this kind of granular occlusion stuff, is... Ooh. You've been adding things to this. I don't remember this. I think what I want to do, or what I'd like to do, is maybe have something that has some kind of sound that reacts when Barbell is occluded. So that we kind of blend in and out. I think that could be kind of interesting. Maybe. Okay. So what do I want to do there then? I guess I think I actually... I think what I want to do is I want to have some whispers. I want to have some whispers that kind of blend in and out when Barbell is occluded. I think that could be really cool. Okay, whispers. Well, let's grab Reaper and record some whispers. Now I'm going to need to think of... oh, is this going to... Reaper going to complain because I'm using my sound card in the... Wait, let's find out. Reaper going to complain about me using the same sound card in 2 different applications? No, it's working fine. Okay. I probably want to turn off... Yeah, no, that. Okay. And I'm just going to... Let's save this project. Let's save it in the black and secret places thing, I guess. Sure. Okay. I'm going to turn that off. I don't care about bars and beats, so let's make that more useful. And now I guess I need to actually... Do I need to whisper something, or can I just make whispering sounds? I'm going to try just making whispering sounds and see what that sounds like. that make sense? I don't know. Let's listen back. I don't know that this sounds like someone whispering in your ear. I think it sounds like someone hissing. It sounds like what I did. Anyway, it's fine. We'll come back to it, and I'm going to use this for the time being, and if I decide it's not good enough, then next time I will record something better. Now I can't remember if does Reaper let me normalize. I kind of want to normalize this. Does Reaper let me do that? I can't remember. I'm sure there's a way, but Reaper has so many menus and options that it always takes me forever to. Oh, here we go. I'll do. And if I think I can just actually no. Let's just quickly. Where's sure. Let's. Not sure about sample rate. I can't remember. Oh, it's fine. We'll just go with this. I don't want to spend too much time fiddling about with Reaper settings. Where are we? Right, Neil's Whispers. In fact, no, hang on. We don't want to render it there. We want to render it into assets, streaming assets, PD asset sounds. There we go. Process. Okay. Right, so now I need to remember how you play a sound in PD. Okay, let's see. I think it's Soundfiler. Let's find out. Read and write sound files, that's what I'm looking for. And then I'll need an array. I'm going to assume Soundfiler can set the size of the array for me, so I'm going to leave it set at 1 to begin with. Let's see, so how do we use this? Do I do dash resize? Is that how I... Oh, wait. Also read SF. I've got a feeling I have a bug. I have an issue on the GitHub about read SF not working with the specific version of libpd that we're using, so I'm going to avoid that. So I guess I want read dash resize. And I guess it would be sounds slash, what did I name it? I named it, nope. What did I name it? Did it not? Oh, I guess it's whispers.wav. I should probably find out for sure, but I'm going to assume it's whispers for the time being. You're going to see my desktop in a second. Oh, I have so many windows open. Assets, streaming assets, PD assets, sounds. Oh, I guess it's, oh, that's unhelpful. Let's rename that. And let's get rid of, oh, well, let's get rid of this. Don't need any of that. And right, okay. Where am I? Yeah, keep that open. Grab you. Now I think if I do this, oh, hang on, that did not do anything. Did I get an error? I did get an error. So I need to actually tell it where to. Oh, need to tell it where to save this into. Okay, try again. Huh. Now, I know Jan has done this. Let's see. So if I go to granular probably should have looked at one of Jan's scripts to begin with. Oh, this is way more complicated than what I wanted. Let's try a different one. Breaking door. That should be one of these. Size. Sounds. Oh, sounds with a capital S. That's weird. It doesn't have a capital S here. Am I using the right name? Right file name? It's whispers.wav, and it's just sounds. Yeah. I've not saved my PD patch. That's what the problem is. Need to save the patch before it knows where to look, don't I? Okay, I'm going to call the patch Occlusion Whispers. And now if I do this, there we go. Okay, right, I've done the first part. I guess I need to load bind this. Also, I can hear my voice. Did something turn on ESP? Do that. Okay, so we load bind to load our file, and then I need to remember it'll be tab read 4. I'm gonna I think for this week I'm just going to do a straightforward looping playback, and then I'll see. Oh, what just happened? Whoa, okay, PD crashed. That was unexpected. All I was doing was moving the window. It's weird. Okay, anyway, I'll try and avoid moving windows again, I guess. Okay, right, so I want tab read 4 whisper array. I should really look up how you're meant to use tab read 4. Is this right? Oh, did it crash because I created an empty tab read 4? Did it not like that? Okay, so then we just feed it a value from 1 to side -2. Okay. To move on to the next sample. So we can just feed it a constant value to a constantly increasing value that then loops back to start in order to basically read through it. And that's really easy in PD because we have the Phasor object. I do, however, need to figure out the frequency of the Phasor object. This is going to be wrong, but I kind of want to hear what it sounds like if I just put in some weird value. And I'm half tempted to just play about with it. So I guess, what do? We need to multiply this value by the number of samples in our array. Does soundfiler return the number of? It does. Awesome. So in that case, if I put in, oh, actually, I don't think I need to put in an F. I think I can just feed this in here, and this in here, and then I do this, and then, oh, is that going to let me? What's happening? What's it do? Let me. Why does this? Why does this not seem to let me? I'm going to quickly save. Weird things are happening. Oh, it seems to let me click this. Hello. That does seem, it's the wrong frequency, but that does seem to be playing through it, so I guess it was working. It was just not highlighting the fact I'd clicked the message box. Okay, so hang on. I guess we want to play back. So it's currently playing back at 1 Hertz, so it's taking 1 second to play from this end, from the start of the file to the end, which is obviously wrong because that was nearly a 30-second file. So Soundfiler gives us the number of samples in the file, and we know that I think I saved it with a 44.1K sample rate. So basically, if we divide the number of samples by 44.1K, we get the frequency, is that right? No, we get the length. We get the length in seconds. So we do 1 divided by the length in seconds. I should not try and do maths in front of other people. I'm not good at it. Okay, anyway, what was I saying? So we divide. Oh, actually, I didn't mean to delete this. But we start by dividing by 44.1K. And oh, and I just realized we probably need to start at 1 because it was saying you want to start at. Oh, help files are saying you want to start at 1, not 0 in the array. So I'm going to do that, and then so this value here, this is going to be our frequency, I think, which I think is the left. Is that the left? Yeah. Frequency is the left inlet. So if I now do this and this, that did not work. Okay, no, what have I done wrong? Okay, oh right, wait, hang on. It's 23 seconds. So I missed the second part of what I was saying. Because I then do I'm just going to grab expr 1 over $f1. We do 1 over this value, and let's just check if that's correct. That looks better. Here we go. Okay, so basically all I've done here is I've done a very kind of convoluted re-implementation of Unity's own built-in audio stuff, which is fine. I do want to, I'm going to add in my, what does it call it, ADC helper. So we can potentially, I don't know if I necessarily want to, oops, what are the inlets again? Oh. Wait, why do I have a separate left and right input? Ah, it's fine. Grab a toggle. So if I do this, you hear it, and this, then we don't hear it. Yeah, that's fine. Okay. Right, I'm going to have to. Okay, I'm going to try and put this into. How do I want to do this? I feel like I'm going to have to do a bit of work to actually. I think I want to kind of activate this and deactivate it at certain places. I think what I might do is I might just actually have it here, only active in this scene, at least to begin with. And then I'll have a script. So actually I need to add in script to change the volume. Based on the occlusion value. Okay. Receive occlusion. Is that what I called the? Because I'm going to use the same receive occlusion. Yeah, I'm going to use the same variable that we're using for Barbell, but I think actually what I want to do is I want to invert it in this case, don't I? Or wait, does Barbell already invert it? No. Okay. So in this case, I want to invert the value. Okay. So that it's only when Barbell is occluded that we hear the whispers, and when it's not, then we don't hear the whispers. That's the plan. Well, I guess yeah, that's fine. Right. So I want to quickly. So which one are we in? Are we in? We're in. No, we're in void 2. We're in void 2. So I'm going to add an object here. I'm probably going to change this in my next stream, but for the time being, this is what we're doing. And I'm going to put you over here because I think this is where I'm going to test it. And let's see. I'm just going to drag. Where are we? libpd instance. Loop. I'm going to leave spatial blend off. And I'm going to grab my, what did I call it? I called it occlusion whispers. Put that in here. And I can I'll quickly test that we can actually hear the whispers. Which actually we won't be able to hear the whispers because I've got that. I've got that occlusion variable in, don't I? Okay, never mind. What I want to do, let's see. So I look at my. Okay, so this is how I'm setting the occlusion in my Barbell patch. Now what I'm wondering is, I just make that an array. Where's that? So that's in Barbell. And here's our patch. I think what I might do actually, I might just make this an array of patches, so we can have as many different patches as we want reacting to the occlusion value. So let's do that. Call it PD patches, and then if we change this, we just do for PD patch dot length. Yeah. Okay. So we can have as many patches as we want that react to the occlusion, and we're using the same name for the variable, so that's totally fine. I just need to come back here and update the inspector. Here we go. So to begin with, we're going to have not 250. Geez. So we have Barbellith and we have Whispers. So both Barbellith and Whispers are going to get the occlusion values sent to them. And I'm going to stick in a print statement here to just check that this is working. Oh, and I'm just remembering, I think I've got a print statement in Barbellith, which I'm going to delete because we don't need that anymore. Oh, wait, do I not? Oh, it's maybe in one of the scripts. Sorry. This is probably not the right time to do this. There we go. Sent occlusion. Let's delete that. Okay. So I'm just going to print any occlusion values that this patch gets. And let's see if this works. Okay, well, Well, that's weird. Whispers, what's Whispers doing? Oh, why is that off? Let me try that again. Let's see what occlusion Whispers is actually saying. Not saying anything, huh? Okay, that's weird. Let's do some other tests. So this should tell us the number of samples. And I guess if that doesn't work, then it's an indication that something more serious is wrong. Wait, hang on, why did pipe print const get turned off? There is a problem with the libpd code that the print stuff is a bit finicky. It's got turned off again. Why is that? Oh. Okay. Printed 0. Okay, so it's getting the... Oh. I guess I walked off the edge. I should maybe fix that. Probably shouldn't... That edge probably shouldn't be that close to the church. Okay, so it's getting the occlusion values, but it looks actually like it's not loading the file correctly. Let's see. I think what's happening here is we have some other libpd instances where this is not turned on, and I've got a feeling that they overwrite each other when that happens. Let me just check. It's a pain, but it's to do with the way. Okay. It's to do with the way that libpd handles those. That's anyway. Nobody cares about that. Let's see. Oh no! Wait, hang on. I misunderstood how. Oh, all of these errors. I don't. A lot of these errors are not to do with me. But I specifically want to see one specific error. Oh wait! What did I just see? I saw a number. Sample length. Okay. Here we go. Why are we getting divide by 0 detected? Oh, do I need to do wait, no. Sample length isn't what I was printing. I was printing num samples. But wait, what's going on? See, I suspect. Hmm. What I think maybe this is the problem. I don't understand why I'm not seeing this. And also, I'm probably not using print correctly. How does print work again? Oh yeah, no, I am using print correctly. So I should see num samples in my console log. But for some reason I don't see num samples in my console log. Oh yes, I do. See it right at the start, and that's probably right. That's a big number, and it should be a big number because it's reading a lot of stuff. So that let's just try with a normal BAC. We're not using the spatialization at the moment anyway. Right. Oh, hang on. Scroll down to the bottom so we see stuff happening. Oh, that's weird. Oh, I guess I don't want to invert the signal at all. Whoops. I just want that. Okay. Okay. It really doesn't sound very good at the moment, but it is at least doing what I wanted it to do. I think it definitely needs actual whispers. I need to prepare with like a book or something to read out and record that next time. Because I think I'm going to stop there, even though it sounds kind of bad. But but it will sound better. And definitely make this work better. I'm going to have a more interesting PD patch rather than something that just continually loops the sound. Yes, okay. I'm going to stop there. And yeah, thanks for watching. And Jan will be back next week doing more stuff, and that'll be fun. So I guess, yeah, I'll see you myself in 2 weeks' time. Okay. Nope, hang on. Where's my OBS? Yep, okay. Thanks for watching. Have a nice night. I'll see you in 2 weeks. Bye.